This is Luke Waldner, and he's been one of our speakers and contributors from time to time. And this talk seems super interesting about animation and web workers. So I'm pretty much going to let him just take off from here. But Luke, thank you so much for doing this talk. Thank you.
Yeah, thanks for having me. So for a lot of applications that I work on, the UI is pretty much just based around these like large complex animations. And so the performance on those animations becomes really important because all the user experience is kind of built around them. So if the user pulls open your website and it's really sluggish because of the animations, then the user experience just kind of degrades around that. And the designers that design these animations and come up with ideas, all their hard work at the end of the day, hours of refining their ideas, just kind of goes down the drain if you're hitting 10 frames per second on these animations. So in the hopes of improving performance across a lot of different devices, I came across WebWorkers and just kind of went down a rabbit hole of how to integrate those with animations and with the idea of improving performance. So that was kind of the impetus of all this. And so I'm going to be going through some slides, kind of talking about web workers, just kind of also the anatomy of a frame in JavaScript and kind of what goes into that, what we have control over and what we don't. And then after that, just step through an example of an animation I built using web workers and not using web workers and kind of digging into the differences and learning about it. So JavaScript is single threaded. It's was kind of designed around this kind of at the inception, because at the beginning we were just dealing with static documents, pretty simple. And each website is kind of contained within one browser tab or one window. So the idea of it being single threaded, really makes a lot of sense because it kind of takes away all these things that the developer would otherwise have to deal with. If you have multiple threads kind of accessing the DOM and kind of changing things, how do you manage that state and how do you kind of make sure that you have control over everything that's going on? And so client-side JS is kind of just built around this idea of it being single-threaded. And it performs well for most applications, but it's not something that's really grown with JavaScript as a whole. JavaScript is still single-threaded for the most part, while modern CPU architecture and all the devices that we use these days have multiple cores. So these devices have all this headroom for computation that JavaScript just traditionally can't really tap into. And a result of that is, the main thread has a lot of responsibilities and has to deal with a lot of things for each frame that's being rendered on the website. It has to monitor DOM and UI events, so like scrolling, clicking, those kind of basic things, respond to those events and execute functions, determine what HTML has changed, then react to that and change the styles on those HTML elements, render them, and kind of composite all of it into a frame that you actually see on the web page. And that has to happen every couple milliseconds. And that's not even taking consideration any JavaScripts that you put into fetch some image or just do anything that's really basic, move around elements, things like that. And so this is kind of a diagram breaking down just one frame in JavaScript, and it all starts with input event handlers, listening to events, then responding to those events, and that's the request to animation frame. Doing some sort of computation to respond to those events, and then sending some kind of output that typically is going to say like add a class to the DOM or kind of change what the user sees, react to the user's input. And then beyond that, you're parsing HTML, recalculating styles, painting the picture that's seen on the web page. And I got this from a really good blog post about kind of the anatomy of frame, and that kind of breaks it down even more. So you can check that out if that interests you. And so, right, so in this is just one frame of JavaScript. So this has to happen, if you ideally you want to hit 60 frames per second with all of your animations, everything that's going on the screen. That's because typically, computer monitors, these kinds of screens run at 60 frames per second. So if you want a really smooth user experience, you want to be hitting that as much as possible. So what that means is that each frame only has 17 milliseconds to finish. And if it's longer than that, then you're going to drop a frame and things are going to get out of sync. And that's when you start like seeing, choppy rendering, things looking a little janky, crunchy. Um, and, it's also worth considering that, a lot of modern phones are shipping with frames or screens that are at 120 frames per second. And then there are even some monitors that run at 144 frames per second. And so that, effectively reduces the amount of time that you have to process a frame by half. Um, and it's also worth considering that, in this diagram of a frame, you only really have control over what goes in the red box, or request animation frame. Everything outside of that, you can have an idea of what's going on there, but you have no direct control over it. And also, if you add a class to an element in the DOM, for instance, you don't necessarily know like what the overhead of doing that operation is going to be in terms of, painting, recalculating like where all the elements are going to lay out and things like that. So it's in a lot of ways, it's kind of a black box. Um, and you only have, limited control over, what's going on. And all this is happening in the main thread. Um, And so, the main thread is overworked. It has a lot of responsibilities, just regardless of any other functionality that you want to build into your application. Because any other functionality that you build into your application happens within, that one square. That's all that you have control over, and so overloading the main thread, it's just going to create a bad user experience, no matter how much time you put into, designing features, designing, how it's going to look. If it's not reactive and responsive to the user, it's not going to feel like a good refined experience. You know what I mean? And so hitting this like 60 frame per second high frame rate, it's important to communicate to the end user, the value of your product essentially. Um, and so ideally, the main thread, it really should only be working on elements that respond to the user so that, the user is getting a really good experience. And it's also worth considering that like, as developers, we work on really modern architecture and hardware that has, really good single core performance. And that kind of ties in with, JavaScript being, single threaded. You know, Apple wants to make sure that their users are getting a good experience on the internet because, that's what most of their users do. So they want to design CPUs that run web pages really well. But the consequence of that is, you know, the majority of the world isn't using modern computers or really nice hardware. So you have to consider, what is the like 50th percentile using? Are they just using like, cheap phones that they like, get handed down? What is the user experience going to be like for them? And so this comes back to the idea of, how do we move these other computations off of the main thread so that the main thread can just be concerned with providing a really good user experience. And so, moving off the main thread means you have to have some sort of like parallelism, multi-threaded. But how do you do that? Because if you have, multiple functions trying to access the DOM and changing things, that can get really messy. And then also, since JavaScript is single-threaded, how do you share memory across threads? How is that going to work? There's a couple ways to do that with like deep copying and array buffers, but that's kind of complicated and doesn't sound very fun to use. But this is kind of where web workers come in. So web workers do operate on a separate thread. And they're really designed to perform background tasks. So if you have a web page that has like 100 images, a web worker could just download all those images for you, decode them, and then send them to the main thread so that they can be painted on the page, things like that. They've been around since 2007 and wide support since 2012. So they're well established, and you don't have to worry too much about browser support. They work in parallel to the main thread, and you can really think about them as kind of headless browser tab. So they don't have access to the DOM in that sense. There's no DOM within a web worker. And you also don't have access to things like Bluetooth, media, USB. So it does fit a like specific use case. If your application is using things like Bluetooth, then that kind of throws web workers out the window. Like they're just not going to be available to you. And there might be ways around that, but it's definitely worth considering. You don't share memory between web worker and the main thread, but you can share variables. And I'll get into that and kind of show some examples. But that mainly happens through deep copying, which essentially is rather than having like sharing a variable itself, you just copy the value of the variable, and now both threads have a like copy of the variable, and it should be the same. And then there's transferable variables, which I'll get into a little bit, but you're essentially like blocking off a space of memory and saying like, okay, both of these threads can share this space. And it's also worth like knowing that web workers are not service workers and they're not worklets. Like we're just talking about web workers right here. And it's kind of easy to get confused because the names are very similar. They operate using the post message API, which is kind of clunky. It's kind of similar to also how WebSockets work. So if you've seen those, this might look a little familiar to you. And as the complexity of web workers grows, when you're adding more and more operations to them, they can get kind of unwieldy and kind of harder to use. And I'll show an example of that. And then they also exist for the duration of the main thread. So, when you close your browser window, the web worker stops working. And so this is an example of a web worker. So if we start in the worker.js, all that web worker is doing is responding to a message event. And in the event object, there's data, which is sent to the web worker, and the web worker does something with that data and then returns some value using post message. And then in our main.js, we create a worker and pass it the path to the worker file. And we communicate with it using post message function. So in this case, I'm passing an array of 2 numbers. And then I listen to the worker for a response, which is the result of that operation. So in this case, it's really simple. I'm just adding 2 numbers. And so now when we add additional functionality, so if I want to add subtraction to it, you only have this one message event that you can listen to. So from that message event, I have to then grab what operation I'm doing and the parameters of that operation, and then figure out, what operation am I doing, and then, do the operation. But then you also have to consider, like, since this is happening in a separate thread, my main thread could, ask for an addition while an addition is currently happening. So now I have 2 messages that I need to keep track of so that I don't send the wrong result to the wrong message. So there's like some bookkeeping that has to happen when these things, get really complicated. And like the main takeaway is workers are just not super fun to work with, and when you're not doing very, very simple things. And so that's kind of where this library Comlink.js comes in. Is developed by Google, and overall it just makes using web workers enjoyable by providing interface that is really familiar to anybody. Rather than using this post message API to like send and listen to events, you're just calling. You just have an object and you're calling functions. and those functions return promises that resolve to the result of whatever operation you're doing. And so, under the hood, it uses proxies to kind of, do that internal bookkeeping and things like that. But none of that is really, you don't have to deal with any of that. And it also provides really nice APIs for sharing variables between the main thread and the web worker to kind of reduce that complexity and kind of overhead of thinking about that. And it has some nice things like the ability to directly bind to event listeners and things like that. Again, just to reduce that kind of overhead of thinking about how to integrate these things and keeping it simple also.
Luke, can I ask? Sorry, I
Yeah.
didn't understand what the proxies were. What does that mean?
It's I wouldn't worry about it too much, but it's just putting, with a web worker, you have this message object, and then you have to figure out what operation you're doing. The proxy is just kind of doing all that management for you. I wouldn't really worry about it.
Okay.
So, and then this is the same worker, but in a Comlink example. So in our worker.js file, it's just a really simple object, and we have two functions: add and display. And then in our main JS, we create the worker in the exact same way, pass a path to the worker file. This time we call comlink.wrap around the worker, and that's kind of all that you have to interact with Comlink. Beyond that, to call the add function, you just call add, pass a couple variables, and then it gives you a promise with the result of that addition. Alternatively, instead of using then, you can use await and just get the value directly that way. And then also, in the worker file, you call comlink expose on the object to kind of expose it. Yeah, what's up?
Yeah, I had a question. So if you actually ran this program, would you see hello world before you would see the addition?
In this case, you just because it's so simple, you would probably see
The addition first?
the addition. It's hard to say, but yeah, I mean,
Because the idea with
if you,
because the addition is happening on a separate thread, right?
yeah, the addition is happening on a separate thread, exactly. In this case, yeah, you would see the addition first because that would execute first. And yeah, in the demo that I give, we'll kind of look at kind of the call stacks, and it'll be a little clearer. And so yeah, so the benefits of moving off the main thread. Since you're moving all this computation that would exist within that frame, you open up a ton of headroom for other functions and different things that you want to do on the main thread, because the main thread isn't doing all this other computation for things that don't even affect what the user perceives. So it opens up a lot of headroom. So like, for instance, in your worker, you could just have a while true loop run, and it wouldn't affect what the user experiences. They'd be able to scroll and click normally. Well, if you had in just a normal JavaScript file a while true loop, everything would grind to a halt and you wouldn't be able to do anything. And so that's kind of where the power comes from, because you're doing all this computational work, but that's not communicating to the user at all, and they're still getting a great user experience. Depending on your application, it can improve your time to interactive scores, because rather than download the web page and then you do all this work to kind of boot it up, get the variables that you need, do this stuff, that all happens in the worker. So the main thread is just concerned with what the user is actually doing and responding to that. And it can get better. You can get better performance for older devices, because a lot of these, especially older mobile phones, they have not great single core performance, but they have multiple cores. So you can take advantage of that, extra computational horsepower. And it won't necessarily make your application faster, but it'll make it more reliable, because, again, when the user downloads it, they're not getting a frozen screen for 3 seconds, for instance, and then things start happening. They're able to immediately interact with it, and then while retaining the same functionality. And so there's a little bit of tooling for it. There's a great Webpack plugin that works very well. It's rollup natively supports it. And I'll show some examples of this, but the profiling in DevTools is really good for it to kind of look under the hood and see everything that's going on. And kind of some tips for Vue. So when I use WebWorkers, it depends on how you use it, but I typically initialize them from the Vue store. And that makes it so you're only booting up the web worker a single time. So for instance, if I'm only using the web worker on the homepage of my website, if I'm booting it up from that page itself rather than the store, then it's going to be booted up every single time the user navigates to the homepage. And so potentially you could have a dozen web workers all running at the same time because of you keep booting it up. And there's a little computational overhead of actually booting up the web worker itself. So it's just an easy way to keep things organized. So this is one thing that caught me when I was actually deploying these things is a lot of the applications that I work on, all of the client side JavaScript and assets are served from a CDN, while all the server side scripts exist on Heroku, for instance. And web workers will get blocked by cores if they're not served from the same domain. And I include the hack that I use to get around that. So it's just something to consider. And so also, since operations are happening off of the main thread, especially with animations, where a lot of times you're running things within this request animation frame loop. If you're doing that asynchronously and you're using a web worker, what can happen is, I have an animation going on a page and then the user navigates to a different page, but that animation loop is still occurring even though you're not on that page anymore and none of those elements exist on the page. So to prevent that, I always use cancel animation frame. And then there's also a close function native to web workers to kind of terminate it or just stop it, and then terminate, which you use within web workers to kind of stop operations. And then I did some, just for the talk, I did some research on other ways to integrate web workers and Comlink into Vue. And I saw this is a really great post about how you could migrate Redux into Comlink. So you could migrate the Vue store into Comlink so that all your, say, if you have a really complicated getter, for instance, where you're iterating through a really large array and looking at different object property, getters that potentially could be really complicated, all that could happen off of the main thread. And then those values are just returned to the main thread so that you can do whatever you want with them. Okay, and now, demo. So I included in the chat, there's a link to this web page, which you guys can take a look at. And so this is an animation that I used web workers for. And so what you're seeing right now, though, is I'm not using any web workers. This is all happening in the main thread. And then I'm also just including the mouse position just to have some other kind of, operation that's happening in the background, just to add a little more noise to the JavaScript. And so this is all happening within request animation frame, which for those of you that are unfamiliar, so this is just the homepage for the animation. And this is in Nuxt, but it's Vue. So the whole thing is just an SVG. And in each of these sections is a path. So if I inspect it, each of these are just individual paths that I'm animating, so the way that the kind of animation works is for each of these sections, I have a couple points and I'm just kind of, doing some computations on them to get this kind of wave-like thing. And so on mounted, I do some like initial, setting up variables and things like that. Specifics, it's not like really important specifically what I'm doing, but just in general, I'm just setting up variables here. And then I call request animation frame, which taps into that, frame loop. So, and then that just goes down here for the update loop, where I update all the points and then generate like polygons from those points, and then set the paths on these, or set the paths in the SVG to actually get it to, do something on screen. And then I call request animation frame again. So on the next frame, it'll run all this again. And that continuous, loop is what creates the animation. And then, so we can take a look here. So this is kind of like the performance, like JavaScript profiler for Chrome. And so when I hit record, Chrome is going to record all of the JavaScript operations that happen on screen, and then it's going to give me a timeline of all those animations. So I'm going to click record, have it run for 3 seconds, hit stop. It's going to load it all up. And so this is what those 3 seconds look like in JavaScript. So I'm just going to zoom in on just a couple. So this is a screenshot of that frame. This is how long that frame took to compute, and then like the equivalent frames per second. So this frame took 12 or 17 milliseconds, and that results in about 58 frames per second. And then down here in main, this is where all of the JavaScript is taking place. So this is the start. This is our request animation frame getting called. And then this is, the update loop itself. And then from there, I update my points, I generate my polygons, I set my paths, and then after that, it's kind of handed off to the browser, and it does what it needs to do with recalculating styles, painting, and then that results in a new frame getting painted on the screen. Does that kind of make sense? So very good. All right. And so what you can see though is, beyond that, like this is pretty good performance-wise. But the animation itself, it's the performance of it is really determined by how many points I'm generating and how many points I have to update. So right now, so if I increase the number of points that I generate, then the performance of the animation will drop down. So now I'm generating like 100 times more points. And if I profile it again, we'll see that those computations take a lot longer. And this graph up here, the green one, that's plotting your frames per second also. And you can see that in general, it's a lot lower. So right here, for instance, this frame took 28 milliseconds to finish. And so that resulted in 35 frames per second. And so also if I get in there, you can see, for each line, how long it took to, finish. And then you can also see in some cases, garbage collection events taking place. So it's really good for, breaking down what's happening under the hood so you can drill into, where problems might be coming up. It's also worth noting that you can also see the CPU usage. So right now it's taking about, 63% of my CPU. And also you can artificially throttle your CPU. So I slowed down by 6 times and now my CPU is pinned at 100%. And so, the problem that I was running into is how do you, increase the performance of this animation? Since there's no way getting around, the under the hood computations. You can optimize as much as you want around like how you're accessing and updating these variables, but at the end of the day, in this animation, you have a set of points that you need to update every frame, and then you need to paint those points onto the screen. And so there's not a whole lot you can do to increase the performance of that. And so now we can look at the web worker version of that using Comlink. And it's the same exact markup. The only difference is in mounted, I'm creating my web worker, calling wrap from Comlink around the worker, and then I'm initializing it with the number of sections, how high each section is going to be, the width of the window itself. Because remember, web workers don't have access to the DOM, so they don't know like the size of your window, any kind of dimensions, any kind of UI that's happening. And then I call update on it, which kind of kicks it off. And so before my update loop, I was updating the points, generating the polygons, setting the paths. In this case, I just call update, and then I get a promise with the data containing all the paths for my SVG. And then I just use those paths and set them on the SVG. Now, you'll see array buffer, and then I'm doing some other stuff to decode that array buffer. So the web worker, well, okay, let's look at the web worker first. So the web worker, I've basically taken all the logic from the animation itself and just essentially copy and pasted it into this worker.js file. I have a similar update function here, where I update the points, I update the polygon. And since I have to send the paths from the web worker to the main thread, these paths are essentially super long strings, like really, really long strings. If normally I would have to do a deep copy of those strings in order to get it off of this web worker thread to the main thread, because they can't share memory. So rather than doing the deep copying for that, I'm transferring it, which in this case, I'm using a text encoder to just convert it into like a bunch of numbers, basically. And these like an array of it's like a, I don't know, like 32 float array object, and that object inherits a like transferable interface, which allows you to transfer out because it gives you this array buffer. So essentially what you're doing is, instead of deep copying values, you're telling JavaScript, okay, this section of memory, I'm going to transfer this section of memory directly to this other thread, rather than going into that section of memory and copying each value in it, if that makes sense. And so that's what you see. And so on the other side, I have to convert this array of numbers now back into text, which I can give to the SVG to like draw and do things with. So I'm just using a text decoder and encoder. And so now if we look at the animation, set this up under /comlink. And so I'll also increase the number of points to match what you're seeing. And so, okay, so this is the same animation, but using Comlink. So if I pull open the JavaScript profiler, record for a couple seconds. Now we're going to see something a little different. So let's just look at one frame. And so it looks very different. So now instead, we got our animation frame fired here. So this is the start of our loop. We got a function call, get update loop, and then it just kind of trails off into nothing. But we see those other paint calls and everything else. And so if we, here, let me close out this. So beneath main, so these are the different threads happening. So we have our main thread, and now below that we have our worker thread. And so here we have our same function calls for updating the points, generating the polygons, doing all that other work that we were doing in the main thread, but now we're doing it in a worker thread. And so it also syncs up because you can see, animation frame fired, function call, and then it gets passed over to the web worker. And now it's all happening outside of the main thread. And then when all that work is finished, then we go back here, to the main thread, we set our paths, and then it all gets painted. And so a result of that is, on the previous example where it's all happening in the main thread, we were hitting, 99 percent on the CPU, but now, we're only getting 70% or 60%. So it's taking a lot of the overhead out of the main thread. And then also what you consider is since all this computation is happening out of the main thread, that opens up all this space to do whatever other computations we want that before was taken up by, just our animation. But now we've freed up all this computational headroom to do other things. And yeah, that's pretty much it. So yeah, I mean, it's just been really good to as a practice, drill into your animations and see what's going on, but also find ways to parallelize them. Because with workers, you don't have access to the DOM, so there is a bit of finessing with figuring out what you can take out of your animations and move off thread while keeping things at a nice 60 frames per second and all that. So yeah, if anybody has questions, that would be a good time.
Everyone's on mute.
Oh yeah, I got a question. I was on mute. Would it be way easier without SVGs? Seems like you had to do a lot of extra steps with the SVGs.
So the SVGs, it's more to do this kind of animation with these lines and just with other elements. The only way to achieve that is with SVGs and this kind of drawing with paths. Because if you're using a div, for instance, you have clip available to you, and that's pretty limited. And also just in how the browser renders divs as opposed to just path, it's really different. SVGs are kind of designed to be inline elements. They're simple line drawings essentially. So the browser doesn't have to consider how SVG is going to interact with other divs and things like that the same way that it would if you're moving around and changing a div. So in this case, it was kind of the only way to achieve this.
Interesting. Are there other things you would use it for, the workers for, besides animations like this? Now that you've done it.
I mean, it really depends on what you're trying to do with that, in your application. I've recently worked on projects where, yeah, you have to download 1,000 images and have it all kind of, look good and happen in a appropriate time. So you could use a web worker, because in web workers, you do have access to things like the fetch API. So in a web worker, you could download those images. You can decode those images, which essentially does all the computational work the browser needs to do to display the image. Just you take out that final step of actually displaying it. So you could use a web worker to download, decode these images, and then just throw them on the browser, on the web page, right when they load, things like that. I've also done it with analyzing the waveform of the user's microphone. You can just grab that byte array of audio data and then send it to the web worker, do whatever you need to do with that, and then send it back.
Really cool.
Sorry, I'm looking.
Go
Sorry,
ahead.
I see your hand, but I can't see your name.
Yeah, go ahead.
Yeah, I'm sorry, I may have missed the beginning of the presentation, so let me know if you already covered this. But the reason why animation is so smooth on the iPhone is because core animation always uses the GPU for all the animations. And on the web, we have web. I'm not so familiar, but we have WebGL. So is there any kind of because right now we're doing everything on the CPU. So is there any easy way of turning UI animation to leverage the GPU on the web?
Yeah, that's a really good question. So certain CSS properties tap into the GPU natively, so like transform and things like that. Beyond that, I think you would have to, I don't have a ton of experience with it, but I think you would have to kind of get into these kind of like WebGL libraries. And I think Canvas also might natively run on the GPU. So that also kind of comes down to what your animation is doing and kind of the requirements built around that. In the, it's also worth knowing that in the profiler itself, it does give you the GPU, what's happening there. And it's just kind of opaque, what computations are actually happening there. Because clearly, some of these functions are tapping into that, but you don't necessarily have like really fine-tuning control over it.
Okay, thank you.
Yeah.
Other questions, anyone?
Hey, Luke, I was late as well. Sorry about that, but I'm curious if you have other examples of animations that you've used, maybe on like production websites or something. I'm just curious of like other use cases where you've applied this.
I would love to show some examples, but just due to like contracts, things like that, I can't really. But you can DM me and I can send you a couple links. But yeah.
Cool. And then the other question I had, I think on iOS, usually like UI interactions are handled on the main thread. I don't know if that's just like convention or if that's how the operating system functions. But clearly, like obviously, here we're able to put animations on a secondary thread. I'm just curious if there are any distinctions between threads, or if they all function essentially the same way, they'll just leverage like different cores.
Yeah, so I mean, mainly with WebWorkers, so the main thread in JavaScript, that's the only thread that has access to has access to the DOM. And so there's a lot of things that go with that, also like certain APIs, like Bluetooth and media. And then beyond that, there are like normal web workers, and then there are also like shared web workers, which is kind of like a different API. And I think it lets you like share web workers between threads that instantiate them. So iframes, for instance, they don't operate on the main thread. Iframes operate in their own thread. So you could have an iframe that instantiates a shared worker that the main thread could then tap into as well. So the JavaScript does have these things, some other things built into them. But in iOS, like in native apps, I believe the like main thread is kind of referred to the UI thread, which kind of gives you an idea of like what that thread should be primarily dealing with. And then iOS, like there's a bunch of like APIs and kind of architecture built around multi-threading that just doesn't really exist with JavaScript because, from its inception, JavaScript was primarily meant to be a single-threaded language. Yeah.
Cool, that's awesome.
Yeah, yeah.
Hi, I was wondering how you set this up, and did you overlap the layers? And can you go over basically step by step how you kind of set those up?
Sure. So let me just, I'm just gonna render the first frame of the animation, just so you can kind of dig into that a little bit. Because especially if you open up Inspector and all of these paths are like changing every frame, it really like grinds your browser to a halt. And really hard to understand what's going on. So yeah, so each of these kind of paths, they're not overlapping. Essentially what I'm doing is For this purple one, the bottom one, I'm drawing a line. Well, I'm generating a bunch of points and then using D3 to connect to those points and kind of just generate one line that's like my wave. And so then I, construct a like SVG path to draw that line, but I'm sharing that line that I draw between each section. So the top section is drawing that bottom line, and then the section below it is drawing that exact same line on top to kind of like sandwich them and match them. And then I'm also doing like a 2-pixel gap between those to get that kind of black line. Yeah, and then I just draw a line, and then I share that line between like consecutive sections to kind of get this kind of interlocking effect.
And so, okay, because I was kind of confused as to how, like, okay, are you overlapping these things? I kept wondering like how how these could waver and you don't see the line. I thought maybe, okay, some of these bands are really fat and some of them are thinner, but I wasn't. So you're just saying that I'm just trying to figure out how the one strip below stays within. I'm just trying to figure out, like, okay, the bands here that you have, let's say with the one with your pink line, you have those lines in each one, but then how the one below it forms. And so the one below it is a backdrop and the one above it. I'm just trying to figure out like how you layered these.
Totally. So I'm just giving each of them a different random color, and that's just the fill for them. But yeah, so this is kind of where I construct all the polygons themselves. And so I have an array of points. And so I have one like point array for each section, essentially. And then this is just kind of some logic to determine like, okay, if I'm the first section, I'm just going to draw like a straight line as opposed to drawing like a squiggle. And then, so I'm getting like the top line and then the bottom line for each of them. So at the end of the day, like down here, I have my top points and my bottom points. And the bottom point for one section is going to be the top point for the following section. So I'm just drawing the same line twice, is all that's happening. And it's like with the uniqueness of SVGs that you can like kind of draw these elements almost like in weird ways, but not actually have them stack on each other.
Oh, I see. And so the 2 pixels, that's basically is the space between them. So the overlap.
Exactly.
I see.
So if I change the background color on this to red, then they're all red.
Red. Right, got it. So it's the black that's the background, not the like. Okay, okay,
Exactly.
okay. Clever, really clever. Are you watching?
Yeah.
Yeah, really cool. Got it. Wow, that's really cool. That's really great.
Yeah. So SVGs just give you a lot of freedom in terms of the kind of things that you can draw.
Yeah, they do. We use them a lot. But this is a really cool kind of variation on, and it's super fast to do. It's really fast.
Yeah.
Any other questions, anyone?
I still have another question. Is that okay if I ask? Have you done anything like a game with this, or have you done anything that's kind of like a walk cycle with this, or?
More so just in terms of the kind of work I do and the kind of websites that I have to work on. I mostly just work on, things like this. In this case, this whole animation is kind of the homepage for a website, and each of these sections you can interact with. So a lot of these animations are kind of built around, what kind of website is it, what the client wants to do with that website, and what kind of like user experience you want to build around it. I personally haven't done a lot of game design or things like that with SVGs, but you definitely can. They're definitely do it.
Okay, cool. Have you done anything with characters or like?
No, unfortunately not. I do a lot of work with like e-commerce companies and things like that.
So these are it's like these little kind of avant sort of like abstract designs. They're very cool.
Yeah, definitely.
Is there any kind of like particular, line in your head where you say to yourself, okay, now it's time to bring in a web worker?
I mean, honestly, after doing this, if I have any kind of animation that's persistent, and that you're putting a lot of user experience behind, like in this case, in order to navigate to any other pages on the site where I have this animation, you have to interact with it. I want to put a web worker behind that, because so much of it, like so much of the performance of it is tied to the performance of the site as a whole. So I guess as a rule of thumb, I would say like if there's any sort of persistent animation that's happening that there is kind of a high performance cost to, you'd want to like see how you can integrate a web worker. And it's also just a way to, if you can't ensure that the performance is really going to be great for all users, using a web worker will ensure that the user can still interact with the site normally and do the things that they need to do, while you might not be maintaining, a smooth 60 frames per second the whole time.
I mean, the idea of also downloading all the images in the background, that seems super useful for every website. That alone seemed like something that I could see everybody using, because a lot of everybody's using animations. I mean,
Yeah.
Aside from having just a handful of images, like it sounds like a super useful use case.
Yeah, definitely. And yeah, I mean, really any kind of like background task that needs to be taking place or that constantly needs to be going on, just taking that out of the main thread is really good.
Cool. Anybody else? Any other questions in there? Trying to look at faces and scrolling thumbnails. All right, well, this is super cool. Thank you so much, Luke. Everyone, why don't you unmute for a sec?
Good job there.
Thank you, Luke.
Yeah, thank you for having me. It was really fun to put together.
Super cool, man.
Yeah,
super cool.
It's beautiful. It really is. It's given us a lot of ideas.
Nice. That's great. And yeah, and I can share links to the slides and code as well. People are interested, definitely.
I assume you wouldn't be using it otherwise, but the Comlinks, I just had never heard of that library before. How much are people using it? I mean, obviously it's supported, it's from Google, but is it heavily used?
I really haven't like seen many people use it, or like, Googling for like Stack Over, like encountering bugs and like Googling for Stack Overflow things, or like, other things like that. There just isn't a ton of information out there. I think a lot of, web workers are pretty clunky to use otherwise, and that has kind of like pushed a lot of developers away from using them. And so I think this is kind of Google's attempt to kind of bring people back into the fold and kind of get people to use them more. And it's a very simple library. You just really call wrap and expose with it, and that's kind of all that you're interacting with it. It's really like a means to, and then to like have a really nice developer experience around it.
Nice. Very cool. Well, thank you again, Luke. It's really awesome. Thank you so much for doing this. We appreciate it. Thank you.
Yeah. Thank you for having me.
Nice. Good job. Very cool. Anyone else? Any other just general Vue talk? We can all unmute now. How do I unmute all? I'll let you all unmute yourselves. Yeah, anybody else? I don't know, just general conversation, Vue, non-Vue, anything else?
You wanted to ask some questions about me?
I may build something with Vue Native soon. I'm curious if anybody's tried it out yet.
I have not. I just want to make sure you're not. You probably know, but that is not to be confused with Vue Native Script.
Okay, no, I didn't know that.
Oh yeah, so like don't confuse the two. Vue
Okay.
Native is a fork off of React Native, and therefore, there's the pro and con of that. Where on some level you have to drop down to React in the event that something goes wrong. Vue Native Script, on the other hand, I think there's like a direct Vue implementation. So for when I was looking at that stuff, that was the one that I was most drawn to. As a total aside, I was just saying this to Luke earlier that like I've been really getting into Flutter, which is Google's put out a like a new framework essentially that's actually, but it's Dart, but like you have to learn Dart, but it's basically like how to build iOS and Android apps, but also Fuchsia in the event that they swap out Android based off the reasons they might have to. But it also creates a browser-based version and a desktop version. I'm getting pretty into that. But if you want to use your JavaScript skills, which now that I'm spending some time with Flutter, and I'm just like, I don't have to learn Dart. When I was looking at the kind of the React Native equivalent, I felt like Vue Native Script felt like the one that might be the closest. There was a talk on that. If you look back at our YouTube channel, I don't know if it was recorded. Now I'm trying to remember, but we did have a talk on it, and uh, they were super pleased. They were super pleased with using Vue Native Script. It was probably a talk we had a year and a half, 2 years ago. So anyway, don't confuse the two. Because there's 10 different competitors in the space. You can do like a PhoneGap or Cordova-ish kind of wrapper. You can do the web views. We're all talking about how to build native apps, by the way, for your phone. Sorry if I got too deep into it with Matt for a sec there. But anyway, that's I'd be curious which one you end up choosing, but just so you don't confuse those two in particular, because they sound exactly the same.
Cool, that's super helpful. Yeah, the goal is to create like a quick V1 of an app across platforms, and then eventually create a native version on whichever platform makes most sense, like based on engagement or whatever. But yeah, definitely curious to try out Vue Native Script.
And again, if anybody else in the room has actually, more knowledge on that, please correct me. But I have more than once done the like mental roundup of like which of these 6 things do I want to use, and it seems that if you want the tool that is the closest to like the, use your same code in JavaScript, when I was looking in that like with that, that limiting factor, then Vue Native Script seemed to be the one that I was the most interested in. And now again, I'm just pulled in the direction of that or learning Flutter, which means learning Dart. So, but I think if I was sticking with my current code, it'd be Vue Native Script. I'd love to see if you have an example.
What are the differences?
Vue. So again, the whole point that when you use the word native, it basically is like a mental shortcut for if you wanted to build a iOS app or an Android app, but kind of like, using mostly your same code. That's what the keyword, like when people talk about stuff that's native, it's like, hey, use your current JavaScript code to build that stuff too, which is a promise that 50 frameworks have promised, and with varying results as to how doable that is. So if you want to build a native app, obviously, like, Apple wants you to build things in their code, and Android wants you to build things in their code, neither of which are JavaScript. So the promise of these frameworks are, hey, use most of the same code that you have now in Vue, and basically be able to build a native app. So you basically have an app on your phone too. Again, like all these things, easier said than done. So there's a lot of the problem is you're basically writing one code base that it has to convert itself to another kind of language and framework and then get it perfectly right. So again, there's just been numerous attempts of people doing that. In the React world, if you were to write React code, there's something called React Native, which is, hey, this will help you build apps on your iOS phone and Android. In the Vue ecosystem, Vue Native Script's probably the closest thing to that. Versus when I was saying the Flutter version is you have to use a completely different another language, which is called Dart, which is a pretty obscure language in the scheme of things. It's pretty much a dead language, with the exception of the fact that it seems like Flutter's really bringing it back to life. And so both of those things are really kind of taking off, together. And so you'd basically learn this whole other framework, but based on a whole different language. And then you'd be able to build iOS apps and Android apps. And then it seems like they're promising, that eventually it'll be able to build your browser apps, etc. too. Anyway, so, but what I have found that's interesting while I'm at it, because I really did spend a few weeks trying to learn just some of the basics of Flutter, was like I found it interesting as somebody who basically learned front end and UI through my learning Vue for the last few years, and how similar the thinking is now, just like across all the different platforms. So you look at Flutter, and what they're calling widgets are basically what we call components, right? And so there's a lot of stuff that I just don't like because I never had to learn it, which is like, like it's all. I mean, it's the language itself, which is again Dart, is much closer to like a C++ or a Java, which is like I've got to do everything, static and like declare a bunch of stuff that I get to like cheat and not do now. But anyway, I find the whole thing kind of interesting. But anyway, sorry, I'm going maybe a little long here. But Matt, I'd be curious to see which one you choose. But Vue Native Script looked like it was really interesting. Oh, and I think that they were like, I don't know if they ever actually got there, but I remember at some point there was kind of talk of like this is kind of like becoming like the official one that's somehow connected with the Vue ecosystem. Even though there's like a I'm sure that there's native script, but there's Vue Native Script. And then there's also, I think there was an Angular version and a React version too, but Native Script was its own beast. Then they created like a Vue version of it. So anyway, the dream is to build one code base. So I'm curious to see which direction you go with.
Yeah, I'll definitely keep you guys posted, and yeah, maybe that could be a future talk.
Yeah, I was just about to say the same. Like, love to see that. Like a very basic to do app or whatever it is. In particular, to have an understanding as to like really like how much of the code is the same, right? Because there's always that promise, but I have no idea how much how much of it is like, oh yeah, but you have to like know how to drop down to get to the camera in a way that like I would never know in JavaScript, right? Like at least me. Anyway, I'd be curious to see like how much of that stuff is actually reusable. Any other general thoughts? I actually had one other thing too, but anybody else? Since we are doing this group, I will throw out one other kind of just general question thought. If anybody else has been reading kind of the general Vue news, which to me is almost like the Evan You news. There was what is it, Vue Vite? I don't know if I'm saying it right, Vite, that was released as 2.0. That was actually written by Evan You, which it seems to be a almost like a Webpack replacement with the dev server. That like, I mean, what he's purporting, and I really do trust him, is like just seems like it's leaps and bounds faster. And I'm sure he wouldn't have built it unless there was a real reason to build something that's better. And like, I'd be curious if anybody has seen it other than even saw the original post. And like if they know anything about it, it'd take a while, I can imagine, for anything to take over Webpack because it's become so dominant. But there's a reason people keep attempting to. And if Evan, you did it, I would think there's good reason. Any thoughts on that? Anybody read about it?
Actually, I think it was the Atlanta Vue Meetup. Actually, did it was either Atlanta or Austin? I can't remember which one. But wait, hang on.
A talk on it?
It was Austin. Yeah, they did. They had to postpone it because of the freeze up that they had in Texas. But they did something called Vite Netlify and FaunaDB. Oh my! And I was doing something and I only caught the very, very last bit of it. But if you want to reach out to them, maybe what they would do is give a presentation to our group. It would be cool because you're to get. And unfortunately, they didn't record it. Which
That's
they
not a bad idea. I might do that. Which one you say it was? Atlanta?
Yeah, well, it was Austin Vue.js, and he just gave it in February, or no, it was in March.
That's really cool. Thank you for suggesting that.
Yeah, so it would be cool because he could talk about like the stuff that he was doing and just do that presentation again, because I missed it and I was like kicking myself that I missed it, and because we'd heard of Vite and we wanted to see what it was about, and we heard it was great, and I missed it. So it would be great to have it, you know what I mean, for him to give a presentation as like a guest speaker and
Sure.
be recorded. Yeah.
That's a great idea. Thank you so much. Thanks, Lisa. It's
I
great.
think Justin Boyston. Justin Boyston.
How do you spell Boyston?
B-O-Y. I'm sorry, it's Boyson. B-O-Y-S-O-N.
I will totally check that out. Well done. Thank you. Any other? I feel like John, were you going to say something? I thought you're.
Oh, yeah, just the Vite. It's Vite, like French for fast.
Oh, it's Vite? Okay.
Yeah, but it's so the nuts and bolts of it is it's using like native JavaScript modules, ES modules, in place of. So right now, when you do development with Webpack, you're building and rebuilding bundles every time you save, and then Webpack hot swaps out those bundles. So this just skips the bundling step. And you're just swapping out actual live files, and that's where the difference of like if you're working in a Nuxt project, for instance, you hit save, usually it takes a couple seconds. Now it takes a couple milliseconds, and so like that is one of those just that's like life-changingly fast. So that's the main appeal. I'm gonna be starting to look into that. I don't know how like successful we'll be able to like swap out, say, like a Nuxt project for using Vite as a dev server, but maybe in place of like a Vue CLI project. And that's probably kind of where Vue 2.0 or Vite 2.0 is going, is kind of a replacement for Vue CLI. But I'm pretty interested in diving into this, especially now that it's like at a 2.0. That's where I start to get like, okay, maybe this is something that's production ready.
Evan Yu is such a savant. Like, he is just unbelievable, man. Just the things he's created in this world. Super grateful for you humans who can do things like that.
You will still need Webpack though to actually like bundle something for production, because like that's not every browser supports native ES modules yet. So that's where that comes in. Yeah, it's exciting stuff.
That's really cool.
And then I was actually going to like comment on your observation on like Dart and kind of you're mentioning like patterns feeling very similar working in a lot of UI and Vue, and like I get the impression that like it's less like a JavaScript Dart kind of thing versus like a client-side developer versus a back-end developer, right? Like there's probably more in common. If you look at a front-end developer and an iOS developer, there's probably a lot more in common in the way that they think about architecture patterns and structuring like componentization than like a JavaScript backend developer.
Yeah, for sure. I was maybe I said it wrong, but it was more that I was only because, like, again, for me, I am new in the UI world, etc. Right? And
no, I just like, I'm agreeing with you. I think that's a interesting observation of how like client side, because the same like the way when you start to look at a Nuxt Vue app with like a decoupled front end, you want to start thinking about structuring your communication with the API and like making sure that like there's not a server-side rendering like controller relying on the back end, right? Like you're thinking in terms of an API connection and getting and local storage and networking and all that, like these similar patterns for iOS and like a modern front end developer.
Yeah, and just the basic concept of like everyone's thinking about building front end into little components, right? That are ever so even more granular, and that you kind of just reuse those over and over again. Like I didn't know to assume that everybody else thinks in those terms outside of the outside of the JavaScript front end ecosystem, and of course they do. I just didn't know that. So for me, that was cool to see.
Yeah.
It's because on the back end we figured out MVC like many years ago, but we're still waiting for the front end to get their stuff together.
I'm sure as soon as front end fully does, then there'll be a whole different paradigm we'll have to memorize.
I believe the new paradigm is what is it, like WebSockets, HTML over WebSockets these days? That's the new hotness.
Oh, is it?
Yeah, that's what I'm like. I'm not even joking. That is like a new paradigm to learn. So it's a like kind of back to server rendered. So you open up a WebSocket and you still get your single page application performance, but like you have an open WebSocket that's streaming like entire HTML chunks to the front end. So what's old is new again.
Very cool. All right, team. Oh wait, there's one other one that I just only because like it's we get to have this conversation once a month. I feel like someone in one of the Slack groups had thrown out another interesting library or something. Does anybody remember what that was? I just felt like it was worth discussing. I can like look on my. I don't know. I'm gonna pull out their Slack real quick. I feel like either Drew or Ellie had posted some other interesting library. Anybody know what I'm talking about?
Looks like Drew posted Vue Node GUI. I don't know if that's
yes, he did. Wait, I'm confusing that with the one I'm scrolling up. Oh, maybe it was just like Nux 3. But both, I guess, are interesting to talk about. Anything in particular worth mentioning about Nux 3 and also about the Node GUI? There doesn't have to be a specific answer. I'm just kind of throwing it out there for open discussion.
The Node GUI looks really cool. Fun way to build some cool stuff. Kind of like that one talk, I forgot his name, who built the whole AWS management system. Kind of like an Electron or something, but this seems like maybe a more Vue way to do that. Do you remember that one? We did it at the WeWork.
All I'm thinking about is I'm pretty sure that's the same talk. That same person was the one who gave the Vue native script talk. That's actually what was going through my head.
Yeah, that's right.
But I'm trying to remember their names. It was like a consulting firm, and like one of the guys was based out of Russia, and they were both really good guys. And I'm blanking on their name right now. Oh, that's right, because they'd built like this. It was almost like a tool that people could like non-technical people can kind of do, like I can't remember if it was like Docker stuff or some crazy stuff like that. And they'd created a desktop version. It was a separate talk about the native script thing. Yeah. Anyway. All right, team. Anything else before we wrap up? Does anybody have any particular talks that they might be interested in giving over the next couple months? I mean, I assume Matt's going to be an expert in Vue native script by next month, but
we'll see. No promises.
Yeah, no, I wasn't even bugging you yet. It's all good. Anyway, well, all right. It's good to see everyone. I'm really hoping that we get to being able to see each other in person, hopefully at some point soon. Probably not.
This was one of the last things I did last year, I think, in public when we were in Santa Monica. And I remember 3rd Street being like a ghost town.
Yeah, I remember being surprised that we were like so on the fence about it. I was surprised that company down in Santa Monica, that events company, let us have the event there. And they're like, no, it was all of us were in that same first week of like, this thing's kind of, who knows what's going to happen. Maybe this whole COVID thing's going to blow over. Anyway.
Still blowing.
Yeah, exactly. All right, everyone. Great to see everyone. Luke, thank you again.
Yeah, thank you for having me. It was great.
Thank you. Really, thank you for putting in the time. I appreciate it so much, everyone. You guys all step up, so we're really grateful. Thanks, Luke. All right, team. We will see you at the next one.
Later.
Thank you.
Thanks, everyone. Have a great weekend, rest of your week. I'll talk to you guys all soon. Bye-bye.
Well, thank you.
Bye-bye.